Continuing on with our final review, number 24, here we want to simplify 1 over x minus 1 plus 2 over x plus 1. What you have to do is get a common denominator here. So I can see then my common denominator is going to be x minus 1 times x plus 1. And I just got to figure out what kind of things are missing to get that common denominator. Once I have a common denominator, I can add them together. So I notice here, this first one, I'm just missing an x minus 1. I multiplied x plus 1 over x plus 1 to get this. So I have an x plus 1 times 1. And then on the second one, the same idea is I'm missing x minus 1. So I have an x minus 1 times 2. Okay, now I can combine them and get common denominators. Since I have a common denominator. So my numerator, I have a 1x plus a 2x, which gives me 3x. And then I have a 1 minus 2, which gives me negative 1. That's exactly what I have here. Okay, number 25, I want to this time solve an equation. And so if I factor this denominator here, notice that that's y plus 1 times y plus 3. Okay, so if I multiply then both sides of this equation by y plus 1 times y plus 3, cross everything. Okay, then as I distribute here, I get some stuff that cancels out. On the left hand side, the first term, the y plus 1, will cancel out. So I end up with a y plus 3. Because see what happens is you have a y plus 1 times a y plus 3 over y plus 1, and those cancel out. Your second term, in a similar way, is y plus 1 times y plus 3 times y over y plus 3, and so your y plus 3's cancel out. And on the other side, you have everything cancels out but the 6. So then you end up with the equation y plus 3 equals plus y times y plus 1 equals 6, which ends up being a quadratic. So I end up with y squared plus how many y's? 2 y's. Bringing over the 3, get negative 3 equals 0. So that's going to be y plus 3 and a negative 1. So I end up with y equals negative 3 and 1. Now, one thing that I forgot to mention is at the very beginning, I needed to check to see what I'm not allowed to have. So here, notice from these and from this denominator as well, that I know that y can't be negative 1 and 3. Since I got, negative 1 and negative 3. And since I got negative 3 as an answer, that's actually a false answer because that was never even possible to begin with. So I'm left with y equals 1. Okay, going on to 26. This time I have a square root involved. So what you want to do is isolate your radical. So I'm going to have the square root of x plus 5 equals x minus 1. From there I can square both sides. So the square root of x plus 5 squared is just x plus 5. And then I have x minus 1 squared, which when I FOIL it out gives me x squared minus 2x plus 1. So now I have a quadratic. I'll get two answers, but I'll need to check my answer. So let's see, that ends up being x squared minus 3x minus 4, which factors then as, so two things multiply give me negative 4, add to give me negative 3. How about negative 4 and positive 1? Which then gives me the answers x equals 4 and negative 1. But notice, when I plug in negative 1 back into the original, I have square root of negative 1 plus 5 minus 1 equals negative 1. Negative 1 plus 5 is 4, so that's 2 minus 1 equals negative 1, but that means 1 equals negative 1. That doesn't check. When I plug in the 4, it does check, and so my answer is x equals 4. Okay, so what happened was when you square both sides, you actually created another solution. Alright, so number 27 says find the distance between the 2 points 2, negative 6 and 3, negative 7. This is, do you know the distance formula? Okay, so the distance formula is the square root of the difference of the y, x's, squared, plus the difference of the y's squared. Alright, so in this situation, I just have to say that's the square root of the difference of the x's, that's 3 minus 2 squared, and the difference of the y's, that's negative 7 minus a negative 6 squared. So that ends up being square root of 1 squared plus, what is that? Negative 7 plus 6 gives me negative 1 squared. So I end up with square root of 1 plus 1, which equals root 2. That's what I have here. Okay, now this comes from the Pythagorean theorem, if that helps. Remember, this squared equals that squared plus that squared. That is actually literally talking about a right triangle here. It's Pythagorean theorem. Okay, number 28, we want to find the midpoint between 2 points. Midpoint formula is just averaging the x's and averaging the y's. That's all you have to do. Okay, so then in that case, I need to just say 2 plus 3 over 2 and negative 6 minus 7 over 2. So I end up with 5 halves and negative 13 halves. That's what I have here. Number 29, I want to find the x and y intercepts. Okay, so for the x-intercepts, what I need to do is let y equal 0. So if that's the case, then I have 2x equals 12, or x equals 6. So 6, 0 is the coordinate for my x-intercept. For my y-intercept, you do the opposite. You let x be 0, which if x is 0 here, then I end up with negative 6y equals 12, or y equals negative 2. So my coordinate then is 0 for x, negative 2 for y, which is exactly what I got there. So there's my y-intercept, and here's my x-intercept. All right, number 30. Determine the slope of the line passing through these 2 points. Do we know the slope formula? The slope formula says the difference of the y's over the difference of the x's. Okay, so since I have my 2 points, it's just a matter of plugging in the slope formula. And we're kind of just quizzing you on whether you know it. So it doesn't matter which point I pick. Let's say I can say negative 2 minus 1 over 1 minus a negative 3. And doing that, I get negative 3 over 1 minus negative 3 is 4. Negative 3/4 is my slope. All right, number 31 says find the equation in standard form of the line with a slope of 1/2 passing through the point to negative 3. Okay, so a couple of things. Point slope formula says y minus y1 equals m times x minus x1. So I can figure out then the equation of the line based on that, but standard form is when I write it like this: ax plus by equals c. Okay, so first of all, let's see, I have y minus my y coordinate, which is negative 3, equals the slope of 1/2 x minus 2. So that means I have y plus 3 equals 1/2 x, what is that, minus 1. So then I have y equals 1/2 x minus 4, right? Okay, but to get it in standard form, what I'm going to do is multiply everything by 2. So I have 2y equals x minus 8, and then just get everything except the constant by itself. So I have 2y minus x equals negative 8. And you can see that there. That's your standard form. This is your sloped intercept form, by the way, as well. Okay, so like number 32, it says find the equation in slope intercept form. So that'd be in this y equals mx plus b form of the line perpendicular to this equation and passes through that point. Okay, so I'm going to use this equation again, this point slope formula, and I have a point, so it's going to be y minus 3 equals, now I need to figure out my slope, x plus 4. Now my slope comes from this clue, perpendicular. Perpendicular lines have negative reciprocal slopes. So the slope of this guy is going to be the negative reciprocal of negative 1/2, which would be 2. So then now I have to solve, and as you do the arithmetic, you'll see that you get 2x plus 8, you add 3, that's 11, and there it is. All right, so now number 33 says find the equation in standard form of the line parallel. Parallel means you have the same slope to x equals 4. Ooh, we have to be a little bit careful because remember x equals 4 is just this vertical line. So parallel line, this vertical, a line that's parallel to this vertical line would also be vertical, and it passes through that point. Okay, so here's the point 25, and it's vertical. Well, vertical lines look like x equals something, And there's your clue. X equals 2 is the line parallel to x equals 4 passing through this point. Alright, number 34, we want to find the standard form of the equation with a circle with a given point and radius. So we have to remember a circle looks like this: x minus h squared plus y minus k squared equals your radius squared. So based on that, and based on what they gave me with this center and that 5, yeah, and I forgot to mention the hk is your center, then I have x minus a negative 3 squared plus y minus 2 squared equals your radius squared. Okay, so then distribute that negative and you just end up with a standard form of the equation of the circle. Alright, number 35 is the same deal. It's a little bit more complicated because what I'll have to do is complete the square twice. So what I'm going to do is I'm going to get the x squared plus 2x. I'm going to say plus something, and then I have a y squared minus 6y plus something equals 6. Okay, now to figure out what these somethings are, I complete the square. So that means I take the middle term, I divide by 2. In the first case, it's 1. And then you square that, which is 1, and you add it in on both sides. Okay, I'm going to do the same thing with the y. So I take negative 6. Let me come over here just so I have room. So negative 6 over 2 gives me negative 3. Negative 3 squared is 9. I'm going to add that in to both sides. Why would I do that? Because now x squared plus 2x plus 1 factors very well as x plus 1 quantity squared. And x squared minus 6y plus 9 factors very well as x minus 3 squared. And then what I'm left with on the other side is 16. And so now I have, if you look at the previous question, the standard form of a circle. And its radius then is from here and here. Oh, I'm sorry, your center comes from there. That's going to be negative 1 and a positive 3. And the radius is the square root of this number, which is 4. So there it is. I have a center of negative 1, 3 and a radius of 4. Alright, number 16, we're going to look at some functional notation. So given fx equals negative x squared plus 2x, find f of negative 3. So all that means is when I plug in negative 3 for x, let's see what we get. So every time I see an x, I rewrite that as a negative 3. And so now I have negative 3 squared, which is 9, times a negative 1. That gives me negative 9 minus 6, negative 15. Alright, so now 37 and 38 are both domain questions. And there are only two things you have to worry about with domains. The first one is even radicals, which we see in number 37. And so all you have to do then is figure out, when is this thing greater than or equal to 0? I can't have negatives in the square root. So for this particular one, that means 2 has to be greater than or equal to 4x. Divide both sides by 4, you end up with 1/2 greater than or equal to x. Okay, now if I think in interval notation, here's my 1/2. And the x is the less than part, but the 1/2 is included. So that's going to be negative infinity to 1/2 with a bracket on 1/2 because the 1/2 is included. Okay? And you do the same thing anytime you have an even radical. Number 38, it's another domain question, and all I have to figure out this time is what makes the denominator 0. So here I need to figure out this equation, and the answers to this are actually things I can't have. So I'm going to say not equal to 0. There's several ways to do this. This one I'll factor as the difference of squares. And so here I see that x can't be 2 and negative 2. And now on a number line, what that looks like is here's negative 2 and here's 2. I cut those out, but anything else is good. Anything else counts. Okay, so that's going to be negative infinity to negative 2. Negative 2 to 2 is good, and anything past 2 is good as well. So to show that those are one set, I use these union symbols, and there I have it. Okay, now conceptually a domain, remember, are the elements or the numbers I can plug into this function and still get a real output. So for number 37, anything less than 1/2 gives me a valid output. Anything greater than 1/2 will not. Okay, if I plug in 10, for example, I get a negative square root. So in the real numbers, that doesn't exist. In 38, I just need to make sure that my denominator is not 0. Otherwise, I'm okay. So as long as I don't plug in negative 2 or 2, this f of x will give me a valid answer. Okay, now moving on to 39. I want to identify the vertex of this quadratic. Okay, well, thankfully, it's in vertex form. Okay, so vertex form, again, is f of x equals a x minus k squared plus h. All right, and so I got those constants backwards. That's hk. And so your vertex will be hk. In this case, I have x minus 1, there's your h, and a plus 3 is your k, so the vertex is negative 1, 3. There it is. All right, number 40, I have f of x equals x squared minus 1, and g of x equals x plus 1. I want to know a couple things. First of all, I want to know the composition, f composed of g of x. Okay, so f composed of g of x means that I take the f function, and as its input, I plug in g. So that means take your f function and replace all your x's with g of x. So that's g of x squared minus 1. And now I can replace that with what g of x actually is, which is x plus 1. So I have x plus 1 quantity squared minus 1. So if I simplify that, that's x squared plus 2x plus 1 minus 1. The 1's cancel, and I with x squared plus 2x. Okay, now the f plus g of 2 just means that I take the f function and plug 2 in, and then take the g function and plug 2 in. So if I plug 2 in the f function, that's 2 squared minus 1. And then in the g function, that'd be 2 plus 1. I think I can handle this arithmetic. You'll see that gives you 6. And that's how we figure that one out. Okay, number 41. Determine if k equals 1 is a 0 for this polynomial. Okay, all you have to do there is do synthetic division. So I plug in 1, and I'll write my coefficients, 10, negative 24, 8, negative 1, and 3. And then synthetic division, remember, you bring down the 10. 10 times 1 is 10. Add. Negative 10 times 1 is negative 10. Plus 8, you get negative 2. Negative 2, which gives you negative 3, times 1 gives you negative 3. Add, you get a 0. If I get a 0, that means that this k equals 1 is a 0 of this polynomial. If I don't, it's not. So it is 1. All right, 42. Use all available methods, including Descartes' rule of signs and the rational root theorem, to completely solve this equation. All right, now if you notice, we can't factor this guy by grouping or greatest common factor, so we have to move on to more sophisticated methods. I'm going to use the rational root theorem. The rational root theorem says that if I take here what I call an, that's the leading coefficient, which is 1, and the constant coefficient, which is 6, if I have a rational root that's p over q, all right, then I know that q has to divide an. So in this case, q can only be plus or minus 1. And p has to be able to divide a sub 0, or 6 in this case. So that would be plus or minus 1, plus or minus 2, and plus or minus 3. Those are the only possible values of p and q. So my rational roots, the only possible things I could have are the combinations of p over q, which in this case is 1 over 1, 2 over 1, 3 over 1. Of course, that's plus or minus all that. So that's what, 1, 2, 3, plus or minus, that's 6 possibilities. Okay, now how do I know which ones work? Well, the way they work is just through synthetic division. So for example, if I pick negative 1 and try to do synthetic division with negative 1, watch what happens. Okay, so I bring down the 1. 1 times negative 1 is negative 1. Negative 3 gives me positive 3. Negative 2, positive 2, I get 8. That's not a 0. Okay, so negative 1 did not work. Okay, now let's try 1. I'm going to clear off some room here. If I plug in 1, so I bring down the 1. 1 times 1 is 1, plus negative 2, negative 1. Then you get negative 1, which gives you negative 6, times 1 is negative 6. Add those to give me 0. Great. That means that 1 did work. And also I have factored this thing now, because this becomes x squared minus x minus 6. So that means my polynomial then is that guy times x minus 1. The x minus 1 came from this term here. And I also know how to factor x squared minus 6 minus x minus 6 because I know two things multiply to give me 3. I'm sorry, negative 6, and add to give me negative 1. Got a little ahead of myself there. That's x minus 3 times x plus 2 times x minus 1. Now we wanted to solve those equal to 0. So that gives me 3, negative 2, and 1. And there's my list. Now, the idea is, if I didn't have this answer, how would I know? Your candidates come from this. So be able to get those from the rational root theorem, and then you should be able to solve it. Alright, now, number 43. We're going to start getting some exponential and logarithmic things. So we have to remember this expression, that a dx equals y is the same thing as log base a of y equals x. When you plug in what your input in for the logarithm is, the output becomes the exponent. Alright, so now here I want to solve this equation. Alright, so I have 2 to the negative x equals 16. So now I can get a common base, which is the first thing you should try with exponentials. That's going to be 2 to the negative x power equals 2 to the 4th. So that means now that I have a common base, I'm allowed to drop and end up with x equals negative 4. Okay, and there's my answer. And I have an extensive video going over the test review from test 4, going over this material in more detail if you need help. Okay, number 44, I want to invest $12,000 at an interest rate of 9%. And I want to find the balance of the nearest dollar after 5 years, and we have these two different compounds. Okay, so what we have to know, first of all, are our two compound formulas. One is this one, and the second one is this one. Okay, the second one is the continuously compounded one. The first one being with compounds that are not continuous, and the number of times you compound a year is what this n value is. Okay, so plugging in the information we have, for the first one, we have 12,000, so this is A, you have 12,000 times 1 plus, now my rate's 9%, so that's 0.09. If you get confused, just think of nines in terms of pennies. 9 pennies is a dollar. I'm sorry, 0.09 pennies compared to a dollar, and we're compounding quarterly, so that's 12 compounds a year. And how many years are we running this thing? For 5 years. So there's my value. Okay, now you have to carefully plug this into a calculator, and you should get about $18,726. Make sure you're getting that number in your calculator. All right, now in B part, we do the same thing. We plug in 12,000 for my P, and then e to the 0.09, that's my rate, times 5. And when you plug that in, you should get about $18,820. Okay, and your continuous compound, if you have the same rate and the same time, the same principal, your continuously compounded investment should be higher. This is going to be the max you can get. All right, number 45, we want to solve 5 to the 1 minus 2x power equals 7. If you notice here, there is no way we're going to get a common base. So if you can't get a common base, the next thing you need to move to is taking logs of both sides. So I take the log of 5 to the 1 minus 2x power equals log 7. The reason I do that is because I have a property of logs that says this, that log of x to the n power is the same as n times log x. That's the whole point of a logarithm, is I can take out the exponent. Okay, so this gives me then 1 minus 2x times log 5 equals log 7. Okay, now here this is a linear equation, so I can just divide both sides by log 5. I get 1 minus 2x equals log 7 over log 5. So the negative 2x equals log 7 over log 5 minus 1. So then I divide everything by negative 2, and it's kind of running off the page a little bit. Let's see, I divided by 2, right? Negative 2, so it's negative down there, plus 1/2. And when I carefully plug this in my calculator, you're going to get this decimal, negative 0.1045. Okay, now number 46. I believe we have a little bit of a typo here. I think we need some parentheses there because I have log base 5 of 2x minus 4 equals 1. Rewriting this as an exponential, I'll get 5 to the first power equals 2x minus 4. How did I do that? I'm using this relationship again. Okay, I'm using that relationship. I started with a log. I went back to the exponential. Make sure you practice that. Okay, so that's 5 to the first power equals 2x minus 4, which means 5 equals 2x minus 4. This is a linear equation. Add the 4 over and divide by 2. I get x equals 9 halves. Alright, the last one is asking me to evaluate log base 3 of 13, and this is going to just simply seeing if I know the change of base formula. And I do know the change of base formula, don't you? It's log base b of a is log base c of a over log base c of b. Okay, now in particular, that c could be anything we want. So why don't we use what's common in our calculators? This value is equal to log 13 over log 3, or if you want to, ln 13 over ln 3. They're the same thing. You plug those into your calculator, and you should get 2.33. Okay, we've gone through 47 algebra questions in a fairly quick amount of time. If you have any questions on this, please let me know. I'll be glad to help. I hope you do well on your test, and thanks for watching.